Imagine standing at a crossroad where you can revisit a cherished memory, and do a mistake, or leap into the future to witness humanity's destiny. Time travel, a concept as alluring as it is enigmatic, has long fascinated scientists, philosophers, and storytellers alike. But is it merely the stuff of science fiction, or could it one day become a reality? Neil deGrasse Tyson, a renowned astrophysicist, has illuminated the intricacies of time and its potential manipulation. But the story of time travel isn't confined to theoretical physics. It's also a tale of human curiosity, paradoxes, and the relentless quest for understanding the universe. In this exploration, we'll delve into scientific principles, captivating theories, and mind-bending paradoxes. We'll even venture into personal reflections and practical lessons drawn from these ideas. Buckle up, this journey through time begins now. At its core, time is a relentless march forward. We're all prisoners of the present, moving continuously from the past to the future. But what if we could break free from this one-way trajectory? Neil deGrasse Tyson often explains that time travel isn't just a hypothetical fantasy. In some ways, it's happening already. Every time we board an airplane or observe a satellite in orbit, we witness minuscule variations in the passage of time due to differences in speed and gravity. These phenomena are rooted in Albert Einstein's groundbreaking theories of relativity. Special relativity. In 1905, Einstein revealed that time is not an absolute constant. Instead, it is relative and can be affected by speed. Particles traveling at near light speeds experience time at a slower rate compared to those at rest. General relativity. 10 years later, Einstein expanded his theory to include gravity's effect on time. Massive objects like planets and black holes warp spacetime, slowing the passage of time around them. These principles form the bedrock of modern physics and hint at the possibility of time travel, particularly into the future. Traveling forward in time is more plausible than going back. According to Einstein's theory, if you could travel at a significant fraction of the speed of light, time would tick slower for you relative to observers on Earth. This phenomenon, known as time dilation, has been demonstrated through experiments. One famous test involved synchronized atomic clocks. Scientists placed one clock on an airplane and kept the other on the ground. After the flight, the airborne clock lagged slightly behind, confirming that it had traveled slower in time. Another illustrative thought experiment is the twin paradox. Imagine two twins, one stays on Earth while the other embarks on a high-speed space journey. Upon returning, the traveling twin would be younger than their sibling, having experienced time more slowly. While these effects are minuscule at the speeds we've achieved so far, they become more pronounced as we approach light speed. This opens a tantalizing window into the future literally. If venturing into the future seems feasible, why is traveling to the past so problematic? Here lies the domain of paradoxes, logical contradictions that challenge our understanding of causality. The grandfather paradox. One of the most famous examples involves a time traveler who journeys to the past and inadvertently prevents their own grandfather from meeting their grandmother. This action would erase the time traveler's existence, creating an unsolvable contradiction. Possible resolutions. Multiverse theory. Some physicists suggest that traveling to the past might create a parallel universe where the time traveler's actions don't affect their original timeline. Novikov's self-consistency principle, proposed by Russian physicist Igor Novikov. This theory posits that any action taken by a time traveler in the past would always have been part of history, ensuring no paradoxes occur. Case study. Imagine a scientist who invents a time machine and travels back to inspire their younger self. While this scenario might seem paradoxical, it could align with Novikov's principle if the scientist's actions were predestined to occur. Beyond relativity, speculative theories like the Alcubierre Drive propose intriguing mechanisms for time travel. This hypothetical concept involves manipulating spacetime itself. By compressing space in front of a spacecraft and expanding it behind, the vehicle could effectively travel faster than light without violating Einstein's laws. However, This requires exotic matter with negative energy, a substance that remains purely theoretical. Quantum mechanics and time. Quantum physics introduces additional layers of complexity. Some interpretations suggest that time might not be linear or absolute but a network of interrelated events. Carlo Rovelli, a theoretical physicist, even argues that time is an illusion, emerging from the interplay of quantum and thermodynamic processes. These ideas challenge our conventional understanding of reality, inviting us to rethink the nature of existence itself. What can we learn from these scientific and philosophical explorations? The limits of knowledge. Just as Newton's laws were subsumed by Einstein's theories, our current understanding of time may one day be eclipsed by new discoveries. The value of curiosity. The pursuit of time travel reflects humanity's unyielding desire to explore the unknown and push the boundaries of possibility. The power of the present. While the past and future remain elusive, the present is ours to shape. By making mindful choices today, we can influence the trajectory of our lives and perhaps the course of history. Consider the tale of a fictional astronaut named Myra. Driven by a dream to explore the cosmos, she embarks on a journey aboard a near-light-speed spacecraft. Decades pass on Earth, but for Myra, only a few years elapse. When she returns, she finds her world transformed, her loved ones aged or gone, yet humanity thriving in ways she could never have imagined. Myra's story captures the bittersweet reality of time travel. It's a testament to the sacrifices and rewards of venturing into the unknown and a reminder of the profound connection between time, change, and growth. Time travel remains a tantalizing mystery, blending science, philosophy, and imagination. While practical time machines may lie beyond our reach, the journey to understand time enriches our perspective on life and the universe. As we ponder these questions, one truth emerges. The real magic lies not in escaping time, but in appreciating its fleeting beauty. For now, the best way to honor time is to use it wisely and live fully. What do you think? Is time travel an impossible dream or a future breakthrough waiting to happen? Let's continue this exploration together in the present.